All right, folks, one of the questions that was asked actually in the, oh, sorry about the wiggly, was 3.79C, but there was another person that requested us to go through 3.79. I'm going to just be going through 3.79 the whole thing, but I've done a little bit of calculations. I'm not going to read this out loud. You know how to read. Please check out your book. So you've got your 3NaHCO3 aqueous, plus that citric acid, which is H3C6H5O7, and it's aqueous. And then I'm gonna put your, I'm also writing it here on the side here in a second. You also have 3 moles of carbon dioxide as a gas, and 3 moles of liquid water, and then you've got some Na3C6H5O7. And that's also aqueous. So it asks you for 1 gram, how much, so if you have 1 gram of sodium bicarbonate and 1 gram of citric acid, which is a limiting reactant? So I'm gonna go through that here under my fancy document camera. Got a couple minutes till the bell rings, so please excuse if the bell rings. I'm gonna zoom out a little bit. Hopefully you can kind of see. Oh, maybe you can't see because it's really blurry. Let's see if we can get it to focus. Nope. There we go. There. Okay. I'm gonna zoom out just a little bit. I'm gonna angle this. There. Excuse that little hiccup there. So again, we're asked for 1 gram of sodium bicarbonate and 1 gram of the citric acid. Here's the full equation. I've already calculated your molar mass. So to start out with, we have to figure out the limiting reactant. So you have 1.00 grams of NaCO3. I'm going to convert that to moles. And if I have 1 mole, I'm going to just call this, HCO3, NaHCO3. And then I'm going to take this, I'm going to move this up a little bit. I'm then going to use from the equation here. Here we have 3 moles of the sodium bicarbonate for 1 mole of the citric acid. So I'm going to say 3 moles of the NaHCO3 for 1 mole. I'm just going to write CIT for citric acid at this point, so we can save a little bit of time on this video. And then we also need to then go all the way to our grams. So then we go for 1 mole of the citric acid. We then have 192.12 grams for every 1 mole. So entering this in the calculator, I'm going to clear out what I had before. Entering this in the calculator, I'm going to do the fast method, and if you do it where you use the parentheses, you can use that too, but I'm going to do the fast methods where I go multiply all the top, hit enter, divide by all of the things in parentheses on the bottom. So I'll do 1 times 1 times 1 times 192, and you probably know that that's going to be equal to 192.12, but I still do it just for kind of explaining that I encourage you to really enter as much in the calculator as you can to kind of make sure that you're accounting for everything. Hit enter. I'm going to then divide by, open the parenthesis, 84.007 times 3, hit enter. So that would mean if I had 1 gram of sodium bicarbonate, I have 0.76 grams of citric acid. So we could continue to process through both of them, but one thing I will let you know, if you get through all of this entire equation, you calculate through and you see that this number is smaller than what you're given the equation 1 gram of citric acid and 1 gram of sodium bicarbonate. So that means, so if I have 1 gram of this sodium bicarbonate, that means as I processed all of it, all I need for this reaction to go to completion is 0.76 grams of citric acid. So what that really means is I didn't use it all. So then if I didn't use that all, that's going to be my excess reactant. So then if I have an excess reactant, therefore then this would be my limiting reactant. So this is what's going to actually drive the whole equation. So our first question on 3.79 was, which is the limiting reactant? So A would be the NaHCO3. how many grams of carbon dioxide were formed. So now that we're actually getting this set up, we know our limiting reactant. That's what's going to limit our reaction. So we're going to use that for the rest of the equation. So B, I'll set that up. I'm going to scoot this up a little bit. There we go. So we'll start out with that 1 gram of NaHCO3. Going to convert this, so it's asking for, again, how many grams of carbon dioxide. So we need to go through all this process using our mole ratio. So again, we're going to go 84.007 grams over 1 mole of NaHCO3. Going to multiply through. We're going to use from our balanced equation. So we've got 3 NaHCO3 moles for every 3 moles of carbon dioxide. So again, I'm going to put the, even though we know that this is going to be 1, I'm still going to include it in there. Then we've got 3 moles of carbon dioxide. And then last step here, it's asking for grams. So if we have 1 mole of carbon dioxide, here I calculated the molar mass of carbon dioxide, it is going to be 44.01 grams. So now we can figure out how many grams can we actually get from this equation of having 1 gram of NaHCO3. So again, I'll do 1 times 3 times 44.01. And you end up with 132.03. Then I'm going to divide that by, open the parenthesis, 84.007 times 3, close the parenthesis, and you should then end up with 0.52, looking at sig figs. We've got 3 sig figs. We've got 0.5234 grams of carbon dioxide. So that's how much you can make of the carbon dioxide if you have 1 gram of that sodium bicarbonate. So then letter C is asking for how many grams of the excess reactant remain after the limiting reactant is completely consumed. So this would have been an easy question for us to actually calculate. So if we have 1 gram that's completely consumed, we used up 0.76 grams of citric acid. But we were given, again, remembering back that we had 1 gram. So if we have 1 gram, so this is your citric acid, is the excess. So then if you have 1 gram to start out with, excuse the bell, I can subtract that from 0.76 grams. 1 minus 0.76 will equal 0.24 grams excess citric acid. All right, you're welcome. See you at the quiz tomorrow or another time.